Alright, so this is 2010, question number 3. So you have these charges at angles, right? And the only one they tell you the sign of is positive. They tell you the force is going to the left. So for that to happen, what must be the sign of charge C? Negative, right? If it was positive, it would push it away. It's pulling it towards it, right? So charge 1 needs to be negative. And then charge 2, positive. So charge 2 is going to push it that way, right? Push against it, cause it to go in that direction. So that should be your that. So that was worth just 1 point if you got them both. Okay. Question B, draw the direction of the force due to particle 1 on 3 and particle 2 on 3. So again, if this is now a negative and this is a negative and this is a positive, is that right? What are they worth? Oh, this one is positive, right? Okay, so this is negative positive, so that's going to attract with the force like this. Okay, and that is F1. This is positive positive, it's going to repel with the force like this. F2. Okay, this was worth 2 points. Basically 1 for each, F1 and F2. Okay, calculate the magnitude of the force on particle 3. So now you're just going to calculate each of those forces. So you're going to use Coulomb's law to find F1. You're going to use Coulomb's law to find F2. So F1, Coulomb's law is, you guys should have these memorized, right? What is it? KQ1, Q2 over R squared, or D squared, however you want to look at it. I'll just write it as R. And you just do it for both. So 9 times 10 to the 9th. F1 was 4 micro. F2 was 1 micro, or F3 I guess in this case. Technically this should be Q3. Divided by the distance, which is 4, and you're going to square that out. Okay, so F1 you should have calculated to be 2.25 times 10 to the negative 3. Is that right? And you're going to do the same thing, right, with 1 and 2 now. You do the same thing, actually 3 and 2. And exactly the same thing, except the distances are different. And you should have gotten 1.7 times 10 to the negative 3. Okay, so I think they're only giving you 1 point. If you got those two, you got 1 point at this point. We do have to find the net. Now when you look at the picture, notice these are at right angles to each other. And so the net force is simply going to be the Pythagorean theorem. So since these are at right angles, if you were to draw it like this and like this, this is a right angle. So you're just looking for the hypotenuse, which would be this way. Okay, so a squared, b squared, c squared. So 2.25 squared plus 1.7 squared equals c squared. And that is 2.8 10 to the negative 3 newtons. Okay, and that would be second point basically for doing some kind of Pythagorean theorem, and the third point for getting the right answer. Okay. Please note when they do, like on the rubrics, a lot of the rubrics now are saying correct answer with units. So make sure you are placing your units on your answers. Okay, last one, oh no, 2 more. D, calculate the magnitude of the electric field at the position of particle 3 due to the other 2 particles. So we're going to remove particle 3, and now we're just looking for the electric field right here. Okay, so you just use your equation, E equals F over Q. Once you know F, then you can basically solve for E, right? Now if they asked you to do this one first, you would find the E field, kind of like what we did. Instead of using the force equation, you just do KQ over R squared and solve it like that. So you're just going to take that answer that you got earlier, 2.8 times 10 to the negative third. You're going to divide it by q. Now, which q are we dividing it by? The q that was actually there, right, that you removed. Because that force was based on q3. That was the force on q3. So q3 was 1 times 10 to the negative 6. So what's this, 2,800 or something? And what's our units for this? Newtons per Coulomb. Okay, so again, calculated answer with correct units. So make sure you're putting your units down there. This was worth 2 points. So basically 1 for kind of this part, and then 1 for the answer. And you got the right answer, right? Yeah, so you could do it kind of the long way, where you basically are doing what you did earlier, but for ease and not for f. Okay, last question. Where are we going to put the x? On the figure, draw an x in a box where if you place another positive charge, it can make it 0. So anyways, it wants to go this way, and this is a positive, so where should you place it? Right there. Okay, so if you place a positive charge right there, it's going to push it in the opposite direction. 1 point for choosing that, and then 1 point for the explanation. Basically, you want to oppose the direction. A positive charge right here will push with the force in this direction, and the net force would therefore be 0. Let's see what they actually said. For example, positive charges repel, and a force to the right would cancel the force F. So 2 points for that. Okay, 4, 6, 8. How many people got a 4? At least a 4, I should say. Okay, most of us.